Logs and exponential functions are basically inverses of one another. If we have any number a, which is greater than 0, not equal to 1, then a to the y equals x, and so we can change that into y equals log base a x. Let's look at some examples of how we can switch these around and calculate these or manipulate them in different ways. Okay, so if you have log base 2, 8, that equals 3, and so we can rephrase this 2 to the third equals 8. Sorry about my writing, still getting used to this tablet. Okay, log base 2, 8 is the same as 2 to the third equals 8, that's true. Next up, if we have f of x, sorry, let's go down here. 10 squared equals 100, so we can say this is the same as log base 10. Log base 10, 100, and that's equal to 2, but we can also call this log 100 equals 2. If we don't have the base written here, then it's assumed automatically it's 10. E cubed, or e to the third, equals x, so we can say this is the same as log base e x equals 3. And this is another special case. Log base e is natural log, or ln, so we could say ln x equals 3. Let's look at a fraction here. Log base 1/3 equals 27, and so we know we should have some kind of negative exponent, right? If x 1/3 is raised to the x power, and that equals 27. And so how can we figure this out? We know that 1/3 raised to any positive power is only going to get smaller, and so this must be less than 0. And so we can calculate if we wanted 3 to the n. 3 to the n equals 27. Of course, we know that number is 3. N equals 3, and so in this case x would equal -3. Next up, log base 25 equals 5. And so we've got 25 to some power here equals 5. And so this must be the square root. And so we can write square root in an exponent form. We'll have 1/2. So this would be log base 25, 5 of 5 equals 1/2. Okay. Next up we have f of x equals 6 to the x, or y equals 6 to the x. Let's change this around into log representation. So we have y equals 6 to the x. In order to make the inverse, we're going to switch the x and y. And so we get x equals, sorry about that, 6 to the y. And if we have x equals 6 to the y, we can write this in log form. Log base 6 of x, or x equals f of -1 of x. Remember, that's the inverse. And next up we have f of x equals ln of x, ln x, so we have y equals ln x, and we'll switch around the x and y's, so we get x equals ln y, and then we can put that into exponential form. Remember, ln is just log base e, so log base e y equals x. That means that e to the x equals y, but in this case e to the x equals f -1 x, or the inverse. And lastly, let's solve a log base equation here. We have an equality, log x squared equals log 9, and so we can pretty much just cross these out, more or less dividing, and so we get x squared equals 9. If x squared equals 9, we'll take the square root of both sides, and we'll get x is equal to plus or minus 3. Let's look at some word problems here. In chemistry, the pH of a solution. This is an application of logarithmic equations, fairly simple actually. we have the equation here, pH equals negative log base 10, or negative log, we don't have to say that, base 10, H positive or H plus, and that's the hydrogen ion concentration. Sorry, there's some work going on outside. I don't know if you can hear the circular saw in the background. Tomato juice. Tomato juice has a hydrogen ion concentration of 10 to the negative 4.1, and so moles per liter. Find the pH. We already have the equation up here, so we know our pH. pH is equal to negative log, we don't need to say base 10, log 10 to the negative 4.1. And so our answer here is quite simple. pH then is equal to 4.1. Right? So 10 to the blank equals 10 to the 4.1. And so since this is log base 10 again, we have 10 to the something equals 4.1. We can cross off these negative signs here. 10 to the something equals, 10 to the 4.1. And so obviously 4.1 is our answer. Next up, the Neuss River. So this one's a little bit more difficult, but not much. pH is equal to negative log base 10, or negative log 1.58 times 10 to the negative 7th. And so if we do the math here, then we get 10 to something is equal to 1.58 times 10 to the negative 7th, and our answer is 6.8 is the pH. Okay, let's go on to a few more applications and rules. So here we have some basic rules for logs. Remember, if m and n are positive numbers and a does not equal 1, then log base a equals 1. Basically, a to the first power equals a, that's our laws of exponents. A to the 0 power equals 1, again, laws of exponents. A to the x is a to the x, of course. A to the log base a of x equals x, so these would cross off. A to the log base a, you get x equals x. Log base a m times n, we can add these two together. If we have a product in our log here, we can just split them up and add these two with the same base. If we have a quotient, then we can split them up and subtract them with the same base. And if we have a fraction here, we can say this is negative log, same base, to the n. Lastly, the power rule, if we have an exponent in here, we can take that exponent and drop it down in front of the log. And all of these work for any log base, including 10 or the natural log ln. Let's look at that first inverse. So we have e to the ln 4.3. Again, this is the same as a to the log base a. In this case, a is e, and then ln is just log base e. So we cross that off and we get 4.3. Very easy in that case. Next up, log base 3 to the root 5 plus log base 3 to the root x. So we have addition here. Let's look, we can change that around. We have the same base. We can make this a product. So we can simplify by saying log base 3 of 3 root 5. Oh, excuse me, no. X root 5x. So multiply these two together. Another product rule, we have addition here, so we can have a product since we have the same base. Let's simplify. This is equal to log base 2 x minus 3 times x plus 2. And we can leave it like that, or we can expand and we'll get log base 2 times x squared. Remember your first terms, x times x is x squared, minus first outside, inside last. Outside is plus 2x, inside is minus 3x, so plus 2 minus 3 is minus 1x. And then we have negative 3 times negative 2 is negative 6. There's our simplified form. Let's look at power. Power says write in terms of log base 3, okay? And so we have log base 10. Let's change, we have log root 3. Right? Okay, so we have 3 to the 1/2 is equal to root 3, of course. That's our laws of exponents. And so we can say log, oh sorry, not log base 3, log of 3, so we can say this is log 3 to the 1/2, and log 3 to the 1/2 is the same as 1/2 log 3. You can put it in parentheses or not. The appropriate way to put it is in parentheses, but if you don't, it's obvious it's the same thing. Next up, log 3 to the x. So again, we're just going to take our power rule, take our exponent and drop it down in front. X times log of 3. Very simple stuff there. Directly applying the laws of logs. If a and b are positive numbers not equal to 1 and m is positive, then we can change base. This is our base change formula. Log base a of m is equal to, we can change the base to b, log base b of m divided by log base b of a. And this is convenient in equations such as the ones we have here. Okay, so I've got ln of x, or natural log of x, right, and then natural log of x plus 5. Okay, so let's change this to ln x times x plus 5, right, because we have our same basis here, we can use the product rule, and that's the same as, that's equal to ln natural log, and again we can use our product rule, so we get x squared plus 4x plus 3, and here we have x times x plus 5, or ln of x squared plus 5x, excuse me, that's equal to ln of x squared plus 4x plus 3, right, get rid of that, and we're left with x squared equals, oops, sorry, x squared plus 5x equals x squared plus 4x plus 3. Our x squared terms drop off, subtract 4x from 5x, we get x is equal to 3. And that's our one-to-one property. We haven't had to change any bases yet. Let's look at our next example. Well, this looks like our power rule here, so we can take this 2 and put it into our exponent there. Then we get log x squared equals log 20 minus x. And again, we've got our one-to-one rule. We get x squared equals 20 minus x. We'll subtract over to the other side. We get x squared plus x minus 20 equals 0. We'll factor that, and we get x plus 5 and x minus 4. Now remember that in order for our product rule to work, remember, for our product rule to work, a does not equal 1. M and a are positive numbers. And so if m and a are positive numbers, that means all of these are positive, therefore we can't have a negative solution here, right, for the power rule. So x equals 4 or negative 5. We're going to eliminate negative 5 and then get what x equals 4. Next up, again, power rule. Actually, sorry, this is an exponential equation. 2 to the 3 x plus 4 Now recognize that 4 is a power of 2, so this equals 2 to the 2 times x minus 1. 2 to the 2 times x minus 1 is the same as 2 to the 2x minus 2. We can drop off our like bases. We get 3x plus 4 is equal to 2x minus 2. Combine like terms, so we'll move our 4 over this side or 2 over that side, and we get x. 3x minus 2x is x, and then we'll subtract 4 from negative 2 and we get negative 6. X equals negative 6. Next up, log x plus, again we have our product rule here, so let's look at log x times x plus 5, very much the same as the first one, and we're going to use our power rule here, log x plus 2 quantity squared, drop off these here, so we get x squared plus 5x equals x squared plus 4x plus 4. Right, our squared terms fall off, and we get 5x is equal to 4x plus 4. Subtract 4x from 5x, and we get x equals 4. Last example here. We have natural log of 6. Natural log of 6, we can combine these two terms, use the power rule. So we get x squared and 6, so we get 6x squared here. We're going to reduce these by using some of our rules. We're going to have our difference or quotient rule over here. We're going to have 38x minus 30 over 2, or 19x minus 15. So we've got 6x squared. Let's move all of our terms to one side. Minus 19x plus 15 is equal to 0. And we can factor this out. This is a little bit more difficult to factor. Let's look at our factors for, our factors for 6. We've got 3 and 2, we've got 6 and 1, 3 times 2, 6 times 1, and our factors for 15, we've got 1 times 15, and 3 times 5. And we know that we have our double negative here. We've got minus minus, so we've got something x minus something, and something x minus something again. And so 3 times 1 is 3, minus 3, and 15 times 2 is 30. Now, so we've got negative 33 there. That doesn't work for our middle term. How about 6 times 1 and 1 times 15? Now we've got 21 as our sum there. 6 times 3 is 18. 1 times 5 is 23. No, that doesn't work. 3 times 3 is 9. 5 times 2 is 10. And so we have our sum of 19. So how about 3 times 3 and 2 times 5. Again, we can check that first. 6x squared, outside, minus 9x, inside, minus 10x, minus 9x minus 10x is minus 19x, plus 15. That all equals 0, and so we can solve then. X is equal to 3x equals 5 and 2x equals 3, so x is equal to 5/3 or 3/2. And later on we'll look at a base change example. It should be a good start for logs and exponential equations. Remember, they are inverses of one another.